Welcome to the fourth session in the Systematic Review Seminar Series. My name is Tom Harrod, and I'm the Associate Director for Reference Instruction and Access at the Himmelfarb Health Sciences Library at the George Washington University. In this session, we'll be talking about the formulation of a search strategy. You can see here the topics that have been covered in the prior videos, as well as the topics that are still ahead. During this session, we will look at the following. We'll start by reviewing some of the things covered in the prior session, including the creation of a research question using the PICO-PO framework. Then we'll look at how to take that research question and begin to develop a search strategy. We'll also talk about potential sources of bias which can creep in during this portion of the project, and we'll end by talking about the role of librarians in all of this. If you watched the prior video, you will recognize this research question as the point at which we left things. We had started with a research topic, then we'd framed the key concepts using the PO framework, and then, by thinking through some of the details of this topic, we'd honed in on a more specific research question based on our initial topic of interest. Now we'll begin the process of turning that research question into a search strategy. This begins by taking the PO elements and arranging them like this: P and E and O. This is a formula for converting a PO formulation into a basic literature search strategy for a database like PubMed. The idea is that we're looking for articles that contain each of those elements, P, E, and O. You can see that represented on this Venn diagram in red. That is what the AND in this formulation accomplishes. This AND is a Boolean operator indicating that the results must include all three things. Here I've substituted in the actual P, E, and O elements from my research question, and the result is elderly, and COVID, and physical activity. This is our initial search strategy. We will use this as a starting point and continue to make refinements. I can just cut and paste this search strategy into a database such as PubMed, as shown here. And from there, I can attempt to identify candidate articles, using them to identify more possible words to add to my search strategy. To do that, I can review the title and abstract to find more synonymous or related terms. Here, I've highlighted several possible terms. Exercise is related to my term physical activity. Older is another way of referring to the population of interest. You'll recall elderly was the term I used in my initial search strategy. Likewise, coronavirus is another term I can use alongside COVID. Additionally, I can use the MESH database to identify potential MESH terms that I can add to my search. MESH is a controlled vocabulary that makes it easier to identify related articles in PubMed. Here, I've searched the word elderly and identified that the appropriate MESH term for that concept is aged. Here we see an expanded version of my original search incorporating the new terms that I identified. For instance, I identified COVID-19 and SARS-CoV-2 as appropriate MESH terms for COVID. For all of these terms, I have made use of PubMed syntax and labeled the terms. You will see the MESH terms. I've added squared bracket MESH after each one to indicate to PubMed that it should treat that as a MESH term. Similarly, for the keywords that I identified, I followed each one with squared brackets TIAB, indicating to PubMed that it should look for those terms in the titles and abstracts of articles. Similarly, for the second set of terms, I identified exercise as a good MESH term. And to that, I added several title abstract keywords: exercise, fitness, and physical activity. And the same for the final set of terms, the MESH term for aged alongside the keywords aged, older, and elderly. You'll notice that I connected all of the synonymous and related terms by the Boolean OR. This tells the database that I want articles that contain any combination of those terms. Another important aspect is the parentheses. The parentheses are placed around synonymous and related terms to indicate the proper order of operation for the search. But the search isn't yet complete. You would want to go through multiple iterations of this process. Identify exemplar articles, farm out more terms, feed those terms back into your search, and run again, find more exemplars, etc. It's hard to know when you're done with this process, but I would say a good indication would be if you are going through exemplars and just not finding any new synonyms or related terms. Be sure to note that the preceding search is formulated for PubMed only. The syntax I've described will not work in other article databases. Which brings me to my next point. You will need to use multiple article databases in order to run a complete search. Here I've listed others that you might consider. One important note is that if you use PubMed, there is likely no reason to also use Medline. You'd be better off using your time on another database. One question that often comes up when doing these searches is, why are there so many irrelevant results? That is, people start looking through the results, and maybe on a page of 20 articles, one is a good match. That is an essential part of doing a systematic review. Your search will necessarily be broad, but not specific. There are two competing ideas with search, completeness versus precision. You can't maximize both because necessarily as one goes up, the other goes down. And given our goal of having a thorough search, it will necessarily be an imprecise search, meaning you will reject a lot of articles. In past sessions, I've referenced the idea of bias within systematic reviews, and this is a place where bias can creep in. For instance, you may decide to only accept articles written in English because you don't have resources to get articles translated. That decision may or may not be advisable, depending on the research question, but either way, you should be aware that it creates the potential for bias. Similarly, if you identify articles in your searches that you can't immediately get full text for, that may introduce location bias, and so it's best to make every effort to find the full text of all pertinent articles. Finally, I want to highlight the role of librarians at this stage. Creating complicated searches with appropriate database-specific syntax is a specialty of academic librarians, and I would encourage you to seek their help. In fact, many organizations like Cochrane also strongly encourage systematic reviewers to consult librarians. In conclusion, during this session, we discussed the idea of converting a research question into an initial search strategy. Then we expanded on the initial search to make sure it's inclusive and exhaustive. Thank you for joining me. As always, here is my email address, tph@gwu.edu. If you are a student or faculty member at George Washington University, please feel free to reach out. Next time, I will be discussing the use of systematic review software, Competence.